Good morning, everybody. I'm Jamal Salawi, full professor of economics at the University of Paris 8. And today we are going to estimate quantile local projections with Stata. So you can find all this information on my website, Econ Macro. We are going to particularly focus on this blog, Quantile LP with Stata, but you can find here on my website. The data what you are going to use is the data coming from this paper. So if you're interested, I encourage you to read this paper. We are going to rely on the local projection package released recently by Alfonso Ugarte Ruiz and at BBVA Research. The documentation of the package is available over the web. You can find it here on my website. And I also encourage you to read carefully the documentation of the package. Okay, let's dive into the blog. So first, I clear the console with CLS, and I clear previous data. I will set up a scheme, indicate the version. I will also remove the more mention. Then I will choose the relative path for my folder, which is this one in my case. You have a relative path for your folder here. Okay. Now I will import the data. The data are in Excel format, so I use import Excel. So the data are, I can show you the data. The data are here in an Excel spreadsheet. So I will generate, so I imported the data. I will generate a time variable using the writing. We start in January 58 and using underscore n -1 to start at 0. So why we have -24 here? Because time is relative, so I need a starting point, and the starting point of the time in Stata is January 1916. So I can format the period variable. So we have now the date variable in a Stata format. I can describe what I have. So I have these variables, and I will label the variables, the label variable on them. And then I will describe again. The variables, the old market variables are coming from the website of Christiane Baumeister from Notre Dame University. So now I will declare that period with capital P will be our time variable. So we understood that we have monthly data, and it starts in January 1958 and stops at 2022 in March. So if you don't install the package, you need to install the package with ssinstall logpurge replace. So I'm going to focus on the impact of the political relationship between US and China and the log of real price of oil, the West Texas Intermediate. There's some small statistics for the variable. So we have 771 months, and we use the log modulus transform of a political relationship index because it includes 0. So the rating is very simple. So you use logpurge, the name of the explained variable, the name of the shock variable. You include lags for your target variable or explained variable, so LWTI, and you include lags for your shock variable, which is a log modulus transform of a political relationship. You can choose a reason, and you can choose a negative reason to check whether you have pre-trend in your shock variable. You save the impulse response, you give it a name. You can use robust standard errors, display with the option noisily each regression, each horizon, and at the end, you will have some statistics about your regressions. Let us run that. So we have 48 horizons, so we will have 48 regressions, and at the end, you will have a panel that show you the impulse response function in one table. So what you can see here is that after an improvement in the relationship between China and US, the price of oil seems to know an increase after 13 months. Of course, it's just unconditional estimate without control, but it's just for pedagogical purposes. So what we have also some descriptive statistics. So the number of degree of freedoms here, and you also have the F statistics along with R squared, which decrease with time, but that's normal. And for example, if you go to this 30th month here, you will have this value, which is 0.16. It's significant at 5%. Yeah. This is what you have in the table at horizon 30. Yeah. Okay, so the significance remains during a couple of months because you have here the standard errors and you have the lower bound for the impulse response function. Okay. So we are going to repeat the process here, but we are going to include the quantile regression model that we are going to use here. And for this, we are going to use the quantile, the first decile, the first quantile, sorry, because it's a 20th percentile. I will not make the graph, save the impulse response function, give it a name, and robust standard errors again. So I will do it for the quantile, the 20th percentile, the median, and the 80th percentile. Each time I will require to not making a graph. Let's go. We are going to make the graph with the lpgraph function, which is very nice and very useful. So here you have a graph for the 20th percentile, and you can see that you have some significance sooner. So now it has been done. Sorry, it was not for the 21st percentile, it was for median, because I didn't include the no graph option here. So it's for the median effect. This is a bit different from the OLS. So if I want to make the graph, it will be very easy. So I use the lpgraph command, the name of the first estimate that you do, or the OLS regression. You choose the label OLS. For the quantile 20, for the percentile, 20th percentile, which has a name Q20. And for the median, it has a name Q50. Choose a reason. I can choose a title for the time axis, a label for the first input function, the second, and the third. Even if you have a fourth, you can add a fourth label, but it's not necessary here. The first, the mean input function will be in red, the Q20 in green, the Q50 in blue. I choose the title with the size. I use the 0 line, give a name for the graph. I save a graph as PNG. Okay, let's go. So what you have here, so you can see that OLS, the lower bound, the lower quantile, the lower quintile, sorry, goes into the same direction where you have a long run positive effect, because if you look at the green, the effect is stronger here. If you find this graph a bit messy, you can add the separate option. And with a separate option, it will give you 3 different graphs. But you may found having the graph into the same graph attractive, which I find quite attractive to have. So now we're going to for me, the median and the 80th percentile. I will give you the name B and save it as PNG. So what you can see here is that, again, most of the OLS is the same, but you can see that for the high quantile, you have also this effect of an increase of the price of oil after an improvement in US-China political tension, so a better relations and reduction in the tensions. And finally, I will make the separate graph without a legend. So I add the separate and the no legend option. And I can show, I choose the color green because I find it interesting color here. So you can see that OLS regression, again, is unconditional regression. The effect seems to be higher when the price fall is more significant when the price fall are in the lower quintile, like the Q20 or the median. And the effect is less strong when the price fall is already high, which makes sense. As we can see, the impulse response function are saved into your data, so you may find interactive to save your data afterwards, but depends on what you want to do. But maybe also presenting the impulse response function in a table could be also attractive for some projects. So basically, we confirm what we had in the previous publication. So the WTI oil prices react positively in the medium run to an improvement in use-channel relationship, and more importantly, for quantiles below the 80th quantile. So that's it for today. Thank you for your attention. And again, I recommend you to read the paper written by Afonso Ugarte Luis from BBVA Research. It's very complete. That's it for today. I thank you for your attention and see you soon.